In order to calculate Gibbs free energy change for a chemical process or for a reaction, quite often people need information of so-called standard Gibbs free energy of formation. Standard Gibbs free energy of formation, or sometimes people say Gibbs formation energy, delta Fg0, F for formation, this O or 0 for standard. Okay, the definition hopefully you learned in thermodynamics is the standard Gibbs free energy of formation for a compound is a change of Gibbs free energy that accompanies the formation of 1 mole of that substance, of that compound, in its standard state from the constituent pure elements in their standard state. Standard state for pure element typically means the most stable form of an element. For example, carbon takes the form of graphite, and oxygen gas takes the form of oxygen. Water at the room temperature will take the form of liquid water at 1 bar of pressure and a specified temperature. So you may have different standard Gibbs free energy of formation at different temperature. And quite often we use 25, but you could have numbers from different temperature. So this is a definition for standard Gibbs free energy of formation, or sometimes people say standard Gibbs formation energy. Okay, it's the energy, Gibbs free energy for a got released, the change to form 1 molar of a compound or substance from the constituent pure elements in its standard state. Okay, so you may find this values for many compounds, not all, but many compounds in standard reference, such as the so-called Geneva thermochemical table by NIST, National Institute of Standard Technology. Okay, they have a website, and here I have a screen capture for one chemical or substance, which is water under 1 bar pressure, and the water H2O can exist as liquid or gas. And the table are tabulated for different temperature in Kelvin, and the column data Fg0 represent the standard Gibbs free energy of formation, and you can see they list the number every certain temperature gap, and at close to 100 degrees C, that's the phase change from liquid to gas. Above 370, around 3 Kelvin, we are in the gas state, but below it, it's in the liquid state. So the standard state, the Gibbs free formation energy are listed here. So this is the column that we quite often will use to calculate Gibbs free energy change for a chemical reaction. Of course, here in this table, you find some other information such as Cp, heat capacity under constant pressure for standard pressure at different temperature, S0 for entropy for the substance, 1 mole of substance at a different temperature at 1 atmosphere, and data FH0 represent the enthalpy change of formation for this same material at different temperature. Okay, so if you have time, you can check out more, but quite often we focus on the column so-called delta Fg, Gibbs formation energy, or Gibbs free energy of formation. Other than Geneva table, you may find some other reference such as CRC Handbook of Chemistry and Physics, and the website online is given here. And of course, you may find some other thermochemical database or sources, and you can check them out. from these standard reference, quite often you can get the standard Gibbs free energy of formation delta Fg0 for different substance, and it is from their pure standard state, the Gibbs free energy change, that gives this value. And for water, you see at 298 Kelvin, it's a very negative number in the unit of kilojoule per mole, a very negative number, which means you form liquid water from the standard state hydrogen gas and oxygen gas, and this is the amount of energy, Gibbs free energy, that got released in this process. The water would be at a lower energy state compared with hydrogen and oxygen in the pure state. By how much? By this much. That's what standard Gibbs free energy of formation means, and it's in the unit of kilojoule per mole. So this number you have to times 1000 to get the unit of joule per mole of this liquid water or gas water. Liquid below roughly 100 degrees C, and ideal gas above around 100 degrees C. Okay.